Hey, hi. Today's topic of discussion will be a common source amplifier with a source degeneration circuit. Okay, whenever we get this type of a circuit, we directly write the modified GM as GM divided by 1 plus GMRS, right? And we intuitively tell that. Intuitively, we'll get this kind of a result and multiply with whatever R out we have. So that will give you a AB, right? So AB is equal to GM minus GM into R out. Okay, but in this circuit we know that gm is not equal to small gm, so we try to find the relationship between the capital gm and the small gm. Okay, so writing down the equations, there are a lot of way to derive this. So you can write the small signal model and just put KVL KCL and get this results, or else you can even go with the control system and other things. So one of they would be this one, that is trying to understand what is capital GM is working and what is trying to understand what is a small GM is doing, and try to find a relationship between them, and finally getting the desired results. Okay, so GM would be change in the output current divided by the change in the input voltage, that is V in. I'm considering I in, I out, I mean, as a current flowing through this, and GM would be change in the I out divided by change in the VGS. This would be 1, this would be 2. Okay, so from the equation 2 I can write GM equal to GM divided by dou VGS, sorry, yeah, dou VGS by dou N. Let us write this equation 3. Okay, and if you keep math aside and stare at that equation, this equation makes sense, right? We are trying to find the ratio of how the GM changes, how the capital GM changes when we have a change in the input voltage. So that is the ratio of change in the gate source voltage to the ratio of change in the input voltage. So writing down the gate source voltage VGS, it would be VG minus VS. VG I can write it as V in minus Vs will be the voltage across the resistance Rs, or as in here it is Zs. Okay, that is I out into Zs is equal to tau Gs V in minus I out Zs. Taking the differential of dou VGS with respect to dou in, will get it as V in dou. This will be 1, and this would be dou I out divided by dou V in. So dou VGS divided by dou in is equal to 1 minus I out divided by dou in into Zs. This I can replace this with the GM divided by GM from the equation 3 is equal to 1 minus, and this we know as the GM into Zs. So working down this equation, we'll get it as GM is equal to GM minus GM into Zs GM. So GM this side, you will get 1 plus GM Zs into GM is equal to G. So GM divided by 1 plus GM into Rs is equal to GM. So this is finally you will get this result from this one. Okay, so we kind of end up with the result with this kind of analysis, but this is not the only way, we know that, right? So if you stare at the circuit, it is just a negative feedback which is given back to the input, right? So if I can draw this GM, this would be I out, and this would be the RS or ZS, a negative feedback. Okay, this would be Vin, and this would be GM, right? So if you go back to the control system, if you compare, like we want to compare this with a standard control system results, control system block diagram. So H of S, okay, negative feedback, and which would be some X of S, Y of S. So at the end you want to find Y of S divided by X of S, and that would be, and you can go through control system, and that would be, if you remember, that would be G of S divided by 1 plus G of S into H of S, right? So if you compare these two, we kind of end up with the same thing, right? So there are different methods, so some of them I have discussed here, but yeah, in the different video we'll try to analyze those methods as well, and try to get into some different conclusions. Okay, yeah, thanks.